we are building a face blur application using the Python and OpenCV. This project automatically detects faces in any image and applies a soft blur effect only on those faces. Perfect for hiding identities and maintaining privacy, just like professional media tools. Before this, in day 16, we learned face detection. Now we are upgrading that knowledge by applying blur only on detected areas, and this teaches you ROI handling, pre-processing, image manipulation skill. Every AI and CV developers must know this. Okay, so in this project we will detect human face and blur the detected region and display the result and save the blurred output and make it work on any input image automatically. So here only one library is needed, that is OpenCV library. So just install, like yesterday we are installed it. So you can open and here type OpenCV Python and click on OpenCV Python first link, and this is the how we are going to install pip install OpenCV Python. Just copy this one, again go to VS Code and click on terminal, open new terminal, and here you can just paste it and click on enter, then it will install. Okay, another thing is what we need, Haar Cascade file also. So for that you can write Python Haar Cascade file or OpenCV Haar Cascade GitHub. So first link you will get GitHub Haar Cascade, and in this first link you will find number of Haar Cascade file we have, that is pre-trained model. So here we are using this Haar Cascade frontal face default XML. So here you can just download it, and after downloading you can keep it on your folder where you are working. Okay, so now let's move into the code. First one, import OpenCV library. So CV2, import CV2. After this CV2 is nothing but the backbone of the project, and here first we will load the Haar Cascade file. Haar Cascade for face detection. So I will create the variable face cascade, and here I given that cascade classifier cv2.data.Haar Cascade. Okay, this is for detecting the face. We are using this Haar Cascade frontal face XML file. Okay, next one, we are going to load the image. So I will create one variable, image is equal to cv2.imread, and here I will give the JPG or PNG file. So this one already I have this image. So in this all India's person are there. So I will just copy their relative path and paste it on here. Next, we have to convert this image into the grayscale image. So convert the image to the grayscale. So for that I will create one variable, gray equal to cv2.cvt color, computer vision color, and image cv2.color to color of BGR to gray color. Okay, so this is, we are converting our image into the gray, print of gray. Let's see. So here it will show the all the NumPy version. So here cv2 dot IMSO gray image. If you want to see that gray image, then you can run this one. So here everything is converted into the gray. Okay. Next, we will detect or we will blur each detected face. So for that, blur the grayscale image, or first one, blur each face in the image. So for that we will use here for loop. In that for loop we will give, okay, let me use for XYWH in the faces. Okay, so before that I will use here one more variable. Faces is equal to face cascade dot detect multi-scale. Multi-scale, and here gray scale factor, minimum neighbors is 5, and also minimum size is 30 by 30 or 40 by 40 we can give. 40 by 40. Okay, so what this detect multi-scale will do, it will return the coordinates of all face present in the image. Every face becomes a set of x and y and width and height. Okay, so let me write here, detect multi-scale return a list of rectangle where it believe it found the faces. Okay, next for loop we will use for xy and wh. Okay, next face of ROI. Here we will give image of x and y of h and x plus w. Okay, so here what is that x and y? X and y, that is the top left corner. Okay, like this is the image, full image is there, so here x and y, it is the top left corner or coordinates. Next one, here y, w and h, what is that? Width and height of the rectangle. Okay, whatever the rectangle we are creating, this is width and height of the rectangle. Next, we will apply the Gaussian blur only the face region. So for that we will use blurred face and cv2 dot Gaussian blur. One of the method we have Gaussian blur, so we will use that Gaussian blur, and in that face ROI 99 and 30. Okay, so what this Gaussian blur, it will take that source and size and sin max, okay, and also sin y. Next, we will place the blurred face back into the original frame. Okay, we will replace the face ROI on the image with blurred version, or here we will place the blurred face back into the original frame. Original frame, which one? Our blurred face. Okay, so for that image of y and y plus h and x of w. Okay, so here no need of this gray image. If you want to print, you can print that. Okay, so now we are showing the output. Blur, display the output or show the output image. So for that I am show we will use, and wait key of 0 we are given. And last, if you want to save the output image in the disk or in our system, so we can save it using the cv2.im write blurred face in the same path. Okay, so this is the code, full of code for making our image into the blur. Okay, so this for loop we are used. This for loop, what it will do, it will extract the face area and we apply the Gaussian blur on the part where in the triangle part, and then we place the blurred output back into the original image. So first you can see the image. This is the image will look like, and after using this Gaussian blur, how it will look. So let me run this code. You can see this display the final image, also save the new file as name face blurred. So all the faces first it is detected, and using the Gaussian blur it's blur all the face. Okay, so that's it. In the just few lines of code we built a tool. Which tool we are built it? Used in professional journalism, privacy protection and smart editing. Okay, so if you find this project useful, helpful, so like, hit subscribe and follow me for day 18, where we move into the another exciting advanced Python project. So this is Yogesh signing off from the Codio. Keep learning, keep coding and keep growing. Thank you guys.